Anyhow, welcome to this talk about Redis in practice. First of all, let me introduce myself. My name is Marijan Šuflaj. Currently, I've been working in PHP for over than 5 years now. And right now, I'm employed in Tricoder and working on a project in Šuflaj. So, let's stop talking about me and let's talk about Redis. Redis has a very interesting history. It was created by a guy named Salvatore Sanfilippo because he wanted to solve an interesting problem. It's a pretty simple problem, but yet he didn't have a right tool for the job. He wanted to keep track for a lot of pages, last end page use. And as you can see, it's a very simple linked list push-pop operation, but no on this SQL database could perform as he wanted them to. So basically, he created a new tool, and later he added some more features. So with time, Redis became what it is today. It's an advanced key value store that has lots of features. So let's see some of them. First of all, in Redis, you store data using different data structures. For example, there are strings that can be interpreted as numbers, so you can increment and decrement values. There are linked lists, there are hash maps, and a few others. Also, there is support for persistence. So in case of some kind of failure, you will not lose all the data you have got in your Redis instance, but you'll be able to restore some of them. Also, there is an application. So, for example, you can say, I have a master that has all kinds of, that has different slaves. So, for example, your application servers can have their own dedicated slave servers that are on read-only. So you can reduce load on your master server that is used only for writes and use Redis clients, Redis slaves just for reading. And one of the most interesting things are Lua scripts. Think of them as extending Redis vocabulary. What you can do with them is create Lua scripts that are executed inside of Redis, and thus reducing network bandwidth and also speeding things up. Let's see something about scaling. Well, scaling is not supported right out of the box. You have to do some manual work or install some other software. As you can see, you can split up, you can repartition your key space and assign each node just a subset of keys that you're working with. Then you can use a few different strategies to achieve that. First of all, you can have your own code that handles all the data remapping, deciding which node gets to assigned to which key, and so on. Then you can dedicate that responsibility to some proxy. For example, you just say, okay, I want to work with this key, and then the proxy will decide which node will work with which key. And also there is something called query routing. There is a currently not stable release, as far as I know, of a Redis cluster. It's using something called query routing, actually hybrid query routing, but I'll explain what query routing is. So for example, you say, okay, I want to work with this key, and you request it from node A. Then node A says, okay, I'm not responsible for this key, but I know who is, so I'll reroute your query to that node. Then that other node will do some work with that key, return value to the initial node, and that node will then return it to you. Hybrid query routing is a similar thing, except when the node figures out it's not responsible for the key, it does not redirect query, but it redirects you. It responds to you, okay, I'm not responsible, but I know who is, so just go ask him. And also, in a talk before me, it was mentioned something called consistent hashing. It's a way, how can you reduce number of keys that have to be remapped when new nodes are added or removed. Then there is vertical scaling. Well, yeah, not so easy. You see, the thing is, Redis is single-threaded, which means at any given point in time, you can only utilize one CPU core. So adding more CPU cores will not help you gain any more performance. But what you can do is create cluster inside of one machine, which means you can spawn multiple instances of Redis, each listening to a different port, and then grouping them into a cluster. So for example, if you have an 8-core CPU, then you can spawn 8 instances, each listening to a different port, and thus you can utilize 8 CPUs since Redis is single-threaded. Okay, so that was a brief intro into Redis. So let's see how does Redis actually work in a production environment. There are more than a few places where we use Redis, and I'll explain two of them, add use and push up. So let's begin. So when you come to a detail view of an ad, a detail view is when you see all the details about an ad. For example, if it's a car, that it is manufactured. For example, how strong is it? Are there any additional equipments and so on? That view is incremented. And before Nushkalo was this big, simple update statement where you increment column was sufficient. And the problem is, as Nushkalo grew bigger, all those queries more and more ended up in a slow query log. So clearly something had to be done. And we decided to try Redis. So after trying through different approaches, does this have a computer? Oh, cool. After trying three different approaches, we decided to keep inside of Redis just delta views, and then in regular intervals flush the data from Redis to MySQL. So what are the delta views? Between two flushes, all the views that have come, those are deltas. So each ad ID, each ad gets assigned to a one key, and that key holds the number of views that were currently that happened after the last flush. And also we use sorted set, that is another data structure inside of Redis, just to help us to keep track in which order to process ads and return them to MySQL. Okay, so this is how slow queries were done, but some new problems came into being. For example, there is a concurrency problem, and there was just too much network utilization. For example, if working with multiple keys, you can say get and then get multiple data. Also, there was just too many requests to Redis. So this is the concurrency problem. For example, this is a timeline. As you can see, this is how do we flush data. First, we get n number of ad IDs. For example, if you're flushing 10,000 ad IDs, then we'll get 10,000 ad IDs to process. Then we will get the deltas for those IDs, and after that, those keys will be removed. But in the meantime, between getting the deltas and removing keys, another view could come in and increment counter that we already retrieved from Redis, and that's the way how we can lose number of clicks. For example, it's not too much, but it's still something that creates data inconsistent and unreliable. So what can we do is use Lua scripts. Basically what we did, we just moved the previous algorithm from PHP to Lua, and basically it returns map of ad IDs with their view counts. It cleans up Redis, it removes processed keys and removes processed ads from that sorted set. The cool thing is that there is now just only one round trip through the network because there is only one command. So when you say, okay, I want you to execute this Lua script, it will go through the network and send all the parameters that it needs and then remove it. And inside of Redis there will be executed multiple commands, sometimes few tens of thousands and so on. And the other cool thing is, if you remembered from the earlier, Redis is single-threaded, which means at any given point only one command can be executed. Since Lua scripts are commands on its own, that means that this is an atomic operation. So basically there is no more concurrency problem and there is no more network utilization problem. In compare to the initial version where Redis was used with PHP and to this version where we use Lua scripts, we are processing 100,000 ads with delta views. It's 7 times faster and 3 times less network traffic. So that's about delta views. Let's see now what is push up. When you come to Nushkalo ad list, those ads are sorted on some kind of column. So newer ads are before the old ads. And if you published your ad, let's say a month ago, chances are your ad will be on a page 17 or less. So push up offers you to offers you to push your ad to the top. So now your ad will be on position 1 until either a new ad is submitted or some other push-up is made. And from our point of view, basically that's a constant time operation, because we only say, okay, I want you to update this column to current timestamp, and that's it. So for example, here is an ad list. I mean, it's a lot bigger, but I just took 2 of them. You have ad number 1 and ad number 2, but the real problem is this column. The thing is, user should be able to see on what position is his ad. And to make things even more difficult, ad can be in one section, and there are many sections. Section is defined by its category ID, model ID, and location ID. So for example, you can see that position of this ad is 2, position of this ad is 1, and those are 1 and 2. And also user should be able to sort on those positions, so he can see what ads are in lower positions, so he can push them back, push them up, so they can be sold faster. And to formulate this problem, it's actually very easy. So you have a category ID, you have a location ID, and you have a model ID. And for every combination of those values, you have one set of ad IDs. And the problem now is, in MySQL, it's pretty hard to get this kind of behavior. And we use MySQL before for everything, so now we had to find some other way. We tried with MySQL a few different approaches, and it turns out that the best approach for us was to just store positions inside MySQL and say, okay, ad ID is on position 1, ad ID this is on position 3, and when push-up would happen, we would update position of that ad to 1 and decrement every ad above it to have lower position. For example, if ad had position number 3, after push-up, it would have position 4 because now 1 is on the top of it all. So basically, it became linear time complexity problem, and MySQL is a bad choice. There were just too many row operations, there are system admins who were crying for help. So Redis helps again. This is something you can very easily achieve in Redis because he has sorted set data structure, and you can define a key that is in this form. So for example, you can have key concatenated with those numbers. Also, it's a logarithmic time complexity to determine its location because Redis can do it really fast. So after transferring our algorithm from PHP to Redis, we got 3 times faster push-up, but we got 24 times less inaudible operation, which is significant. And also sorting is faster because now Redis does all the job for us, and we just say to MySQL, okay, here are your ad IDs, give me the data for those ad IDs. And that's basically it about push-up. So next topic, Lua debugging. Yeah, it's a very interesting thing because scripts are executed inside of Redis, right? And they're not so easy to debug. At first, our scripts were few top of 10 lines of code, which is not very long, and it's easy to develop them and it's easy to debug them. But with time, as we used Redis more and more often, our scripts grew bigger, and it was kind of a pain in the ass to debug them. So we had to find a better tool for our job. I researched Google a lot, and I didn't find anything. So I thought to myself, okay, let's see if we can do something on our own. We know that Lua script as it is has its own debuggers, has its own editors, I mean like Python, like PHP. You can write Lua script and do something for you. So why just not debug Lua as it is and provide inside of your Lua script some kind of Redis-like environment? And basically that's what I did here. This QR code is for this link that will guide you to a blog post about some simple Lua debugger for Redis. It's not much, but it for now, it's the best tool that I have. It does the job done. It enables you, for example, remote debugging. It enables you to step through code step by step. Next thing that you can do is you can inspect stack trace, you can inspect what are states of the variables. I mean, you can do pretty much everything we couldn't do without it. What's this? Anyhow, soon I will publish an updated version. I just didn't have time to do it so. Also, it will be published on GitHub, so everyone who wants can contribute to it. It's early, let's say early release, but the last few months that I've been using it really helped me a lot. So, what's the final word? As guys before me said, Redis is cool, Redis is awesome. I've been talking to a few guys, and Redis is probably the only thing that didn't break in their system, so it's working really well. If you can use it, use it. Don't be afraid to use new technology, but if Redis is not the right tool for the job, then find it. You cannot bake cookies with hammer or something like that. So just use the right tool for the job. It will make your life a lot easier. But I believe most importantly, if one does not exist, well, create it. Chances are a lot of people are facing same problems as you, and if not, okay, let me rephrase that. A lot of people are facing same problems as you, and probably your solution may not be, best or solve all the problems in the world, but it could guide other people with more knowledge to create some foolproof software that will a lot of other people use. For example, take for example Redis. It was created by the same guy, but it was created for one single purpose. He didn't have a right tool for the right job, and currently it's a software that a lot of people are using, and it's constantly getting better and better, and it's extremely fast. Same goes for my debugger. I don't have a lot of knowledge about Redis internals or Lua, but currently it works great, and probably some of you who have better knowledge than me will take it and create something that works extremely great and fast and will help a lot of us. So we will not lose our heads. Yeah, thank you.
Questions? Hi. So, we'll go back to the Lua scripts. No, it's fine. Since Redis is single-threaded, I'm assuming that Lua script is blocking.
Lua script is what?
Blocking.
No. We created our scripts to take a parameter how much items should process, so they are finished in like about 15 to 50 milliseconds. So they're not blocking other requests. They're not long-running scripts.
Okay, but that's something you have to take care of yourself. So you have to make sure that it's a quick script, right?
Yeah, you have to make sure that it's quick, but then again, processing, let's say, 1,000 commands using one script will give you a lot more benefit than doing it from PHP because it will not take that much long to execute it, and yet again, not too much round trip to the network will be done.
Okay, great. Follow-up question. How does it handle Lua script breaking in the middle? Because it could leave data in an inconsistent state. Does it have a rollback?
Well, yeah and no. Basically, only time when Redis breaks is when you have a bug in your code. So it's an optimistic approach because, okay, let's see how can I say that better.
But it could break just because of hardware failure or anything. How does it ensure?
If it breaks because of hardware failure, you're screwed anyway.
But say transactions in SQL databases will handle that. They will keep this data in a valid state.
Yeah,
so if your
script, that's why we don't keep any relevant data inside of Redis.
Okay.
If it breaks loose, if it drives a state union, if you drive some inconsistent state, everything that is stored inside Redis we can recreate and use it again as it is. And for example, that processing these values, well, yeah, it could, I mean, I believe it will not ever break because it's just loading values,
okay, but I mean, so basically Redis, it shouldn't be a primary storage, right? It has to be
without replication, no.
Or if it is a primary storage, the script should never place data in an invalid state.
I mean, if, for example, if you're writing in PHP code, your code could also break. I believe you can, Redis has, when you use it as a Lua script, Redis has two ways how you can execute command. You have redis.call, which in case of failure breaks some script, and then you have another method, I'm not quite sure how it's called, but that one just returns an error. It will not break your script, so you can, inside of your script, create an if statement that says, okay, if my response is error, then roll back. So you can create rollbacks.
Okay, so it has a rollback built in.
What?
So it has a rollback built in?
Yeah, you have two different approaches how you can execute command inside of Lua. You have redis.call, which will break on an error. I hope I explained you. It's in English, so.
Okay, another question.
I believe it's going to be fine.
Yeah. One of the issues with Redis we had was basically Redis tries to keep the whole dataset in the memory at all times, which means if you have like a spike on a Redis, it's gonna quickly spike with memory usage, and if you have a VPS with a small amount of memory, the OM killer is going to start killing Redis. How do you defend against that case where you start running out of memory to actually keep the Redis running? How do you prevent that from happening?
We have our own dedicated servers that for each instance of Redis we have a lot of RAMs, so basically we're not facing that problem, so I don't know what to say to you. No, really. I mean, Redis is using about 1 gigabyte of memory storage, and it's dedicated about 4 or 5. So will not so easily run out of memory since Redis is really optimized regarding the memory. So I don't know, 4 million keys storing 4 million integers will take up, let's say, 4 megabytes and some bytes. So yeah. We need a lot of data to use 5 gigabytes per hour.
Okay. Did you try to write some pipeline code in PHP instead of using Lua scripting? So.
Yeah, pipelines are great when you just have writes. But most of our scripts are dependent on read a value, then decide what to do depending on that value. And that's when Lua scripts come in. I mean, you have transactions, and you can use a watch key. Probably some of you wonder why did we use, when we were here, why did we assign each edit to one key and not use hashing? I mean, using that we could get rid of memory, network utilization problem, because you can get Hermaget and provide multiple keys, and in one single command you will get all the data. The problem is it's hard to get rid of concurrency then. So Redis has transactions, but you can read the value and then write. And transactions are only for writes. And then you can use a watch key, I mean watch command, but it cannot watch hash key inside of a hash map. So we had to split that to different keys, but that turned out also to be bad because Redis is using optimistic looking, which means in case of when you're watching some key and that key changes in between before you commit your transaction, your transaction will be discarded. It will say you cannot do it. So and then one thing you can do is try to retrieve. Well, the problem was there was just a lot of writes to Redis, and our flushing mainly too many times had to retrieve, so Lua script was a better option.
Thank you, Marijan.